All right, so let's check out, this is problem number 5. And in problem number 5, we're going to be using what they call the T distribution table. You will be using this table anytime that you have what they call the sample standard deviation. In other words, you do not know the population standard deviation. And again, they'll tell you that in the problems. But on the next couple of problems, we're going to practice how to use the table to get what's called the t-value. So you have to go to Appendix B in your textbook, and what you're going to do is you're going to be looking up some numbers. Now, on the first one here, let me illustrate. Let me get my stylus on, and so I can draw this out. So typically, with the t distribution table, you do what is called the degrees of freedom, which is defined as sample size minus 1. So in the first one, the sample size is going to be 12, and then degree of confidence is 95%. So again, degrees of freedom is what you'll need to go to your table. There'll be a column called DF, degrees of freedom, which is your sample size minus 1. And then for your Appendix B, they'll give you a column that simply says confidence intervals, and you want to find the confidence interval that is at 95%. So let me show you that. So you'll notice, again, here's your t distribution table, and the confidence level is right there. And at 11, that's going to give you a t-value that's right at 2.201. That's the equivalent of the z-value you would have used from your normal curve table. All right. All right, so let's go to the next one. And so in part B, you'll notice that it says sample size is 20 with a confidence level of 90%. So with a sample size of 20, you'll do 20 minus 1 and minus 1, which is 19, and then find that confidence column in your t-table, and then that's going to give you 1.729. And again, let me show you where that's at. And again, here is your table, and you'll notice again at the top, here's your column of 90%. And you're looking for, again, a sample size of 19. It's going to be right below there. Let me move that down. And then you can see, there it is. There is the 1.729, which is right there. There you go. So that's how you use it. All right. Let's see. The last one on this particular problem, it says sample size is 8. Confidence level is 99%. So again, we'll go to your t-distribution table. Let me go back over there. Let me switch screens here. And again, you want a sample size of 7, or sorry, degree of freedom of 7. You can see that the confidence interval is at 99%, and a 7 is going to give you right at 3.499. All right. Okay, guys, that's how you work the t-distribution table. Let me go back. All righty, so that was problem 5. Problem 6 is going to be basically the same thing. And so when you go through each one of these, let me just kind of remind you, I'll annotate a couple things on here. For part A, when you got a sample size of 15, you would be using, again, degree of freedom equals n minus 1. So you'd be using 14, and then just find that confidence column in your t-table, and you should find 2.145. On part B, your degree of freedom looks like it would be 23. Find the column that says 98%, and that'll give you, you should be able to find that 2.5. And then the last one with a sample size of 12, again, that'll be degree of freedom of 11 in minus 1, and then find the column for 90%, and you should be able to find that number in your table. Very similar to problem number 5. All right. So this 5 and 6, we're primarily just practicing using the table. Now let's go to 7. And here's where we're going to use the table in our confidence interval. So in this problem, read through it. Notice they say a sample of 20 chickens shows they produce an average of 20 eggs per month with a standard deviation of 2. That standard deviation is the sample standard deviation. In fact, everything in this problem is the sample. We do not even know the population. So in part 1, the population average is unknown. Part B, our best estimate would be whatever our average was from our sample. So I'll just kind of make a note here. What I typically describe that is simply your sample mean, which I'll just say that's X bar, which is your sample mean, which is 20. Sometimes they refer to that as your point estimate, but that's what we're going to be using as our approximation of the population mean. So they want us to do a 95% confidence level. And again, our sample size is 20. So you'd have to go to your t-table using degree of freedom of 19. And then you'll look up at 95%, find that column. You should be able to find a value of 2.093. You'll find that in your t-distribution table. So what's left then after that, they want you to do the margin of error. But let me page you down here so you can see what's going on here. So when you do the rest of the formula, if you remember, your confidence interval formula is X bar plus or minus your t-value multiplied by S over the square root of n. And it's that t-value, it's this part right here, the t-value multiplied by your sample standard deviation divided by the square root of n. That is what they call your margin of error. So that's what they're referring to there. So in this particular problem, to get the values, if you plug it into your formula, I'm going to show you right at the bottom since they already have it annotated out for you. It's simply right there. It's your t-value multiplied by 2 over the square root of 20. 0.94 is what they would have come up with for your margin of error. So that's where they would have gotten that. All right, because a minute, let me go back up to the top. Your standard deviation was given right there at 2. So that was S is equal to 2. All right, and so once you get that, you know that simply your X bar is 20. All you got to do is take 20 plus or minus 0.94, and that's going to give you your confidence interval. You'll have the low number about 19.06 and the high number right at 20.94. So that's how you work that one. And then the rest of it, I think you can kind of fill in the pieces right there. All right, that is number 7. Number 8, same thing, very similar problem. They give you a sample of 16. Your sample size is 16. Notice yearly consumption is 45 gallons. Sample standard deviation is 20. Population means unknown. 45 is X bar. So I'll just kind of remind you, I'll make a note as I go through this again. So this number right here, which was given in the problem, that is called your sample mean. And again, then they want you to do your margin of error. Again, using the t-distribution table. So remember, since our sample size is 20, I'm sorry, is that right? Yeah. I'm sorry, sample size is 16, excuse me. Sample size is 16, so your degree of freedom is going to be 15 on this one. And so in this particular problem, you have to go to, again, back to your t-distribution table. And it looks like in this problem, they're wanting us to use, I believe it's a 90% confidence level. I don't know why they didn't show that in C, but your confidence interval, you can get your t-value. And of course, to get your margin of error, it's going to be your t-value multiplied by S over, of course, the square root of n. And so let me, again, show you the specific calculations on that right down below. And I think when the authors put this together, they got that backwards, because you actually, you need that t-value in actually part C to get that margin of error. But then there's your t-value, 20 over the square root of 16, so about 8.765. And of course, you would have needed part D to get part C. So I think they got that one backwards, so don't let that confuse you. But then once you do get that margin of error, just remember that it's simply your formula is X bar plus or minus your margin of error. And so if your sample mean is 45 plus or minus your margin of error of 8.765, and then that's going to give you your answer right here. You'll get the 36.235 up to 53.765. All right, so that's how you work the t-distribution table. You always use that when you do not know sigma. That's simply for always for your sample standard deviation. All right, now on 19, this is a throwback. You have to actually calculate the sample standard deviation. So in this particular problem, this is our sample data right there. it's a sample of 15. The sample standard deviation is not known, but you can calculate it using your formula on how to calculate sample standard deviation. And then once you do that, you can go to your table, get using a 98% confidence, and then remember you're still using X bar plus or minus your t-value multiplied by S over the square root of n. So in this problem, really the only thing you don't know is, and you can find the t-value in your table, but you have to calculate the sample standard deviation. Now, in case you've forgotten, let me pull this up. I went ahead and I plugged the numbers into Excel, and I showed you, just as a reminder, you can look at this. Let me share this with you real quick. So, and again, here's your formula. You know, here's all your samples. It's X minus X bar. Your sample means 21. You square it, you add it up, divide by, or you get 520 over n minus 1. So 520 over 14. You get your sample variance, and of course you can get your sample standard deviation, which they took this one out like 6.09449. So when I go back into the problem, let me just show you this. You can see at the bottom here, they're showing you that 6.09449. I don't know why they took it out that many decimals, but in any case, here's your t-value, and of course, hopefully you can then come up with your confidence interval. All right, so that's my comments on 9. We've got 2 more to look at. Last 2 will be on proportions. So when we're in a proportion, remember we're back to using the z-value. The only time you use the t-distribution table is with your sample standard deviation. So for the proportion, typically with proportions, they always give it to you in decimals or percentages. So in this problem, you'll notice that they say that the population, they want the proportion who pay at the pump, and you got 100 customers, 85 pay at the pump. So what you have to do is, just like we have X bar is our sample mean, I like to say P bar is our sample proportion. So you'd say P bar would be 85 over 100 or 0.85. And so once you know that, you simply plug in your P bar plus or minus, and then again, you're going to calculate your margin of error. Now the formula in this one is a little bit different than your other ones. So when you plug it in, let me get back to my stylus here. So you would go P bar plus or minus, and again, whatever your Z value is, multiplied, and this one's going to be a little bit different, but you would do over the square root of P bar times 1 minus P bar all over N, and that is simply going to be kind of like your standard error calculation. So in this problem, you would have 0.85 is your sample proportion. Your Z value at 95% would be right at 1.96. And then you're going to multiply that out times the square root of 0.85 times 1 minus 0.85, which is, of course, 0.15, all over 100. And again, they're going to show that to you right down there. And then that should give you your interval, which is right at 0.78 up to 0.92. Typically with proportions, they like to give the answer in decimals. Okay. All right. One more, which is your last one on proportions. And again, it's the same thing. And so in this one, they take a sample of 400, 250 would watch it. So the way they would get that is you just take 250 divided by 400, which is about 0.625. So then here's your formula. There's your P-bar. They want a 99% interval. Your Z value is going to be about 2.58, 2.576. They took it out 3 decimals. They rounded it out, or they averaged it out. And then there's your formula. You just plug it in. Notice P-bar times 1 minus P-bar divided by your sample size. You plug it in, and you should be able to get your confidence interval. Looks like they took this one out to 3 decimals. Okay. All right, guys, I think that wraps it up for my comments. Yep, that's number 11 on your Chapter 9 homework.